Hello there. Welcome to our next edition of our Flip Learning Classroom. Now, today's lesson is all about the transition metals, which are the majority of the metals on the periodic table. Now, I hope you enjoy this, and we go on to our objectives now. Bye for now. Okay, so let's have a look at the transition metals and our objectives for today's lesson. So, by the end of this video, you should understand a description of the properties of the transition metals and the uses and reactions of the transition metals. The transition metals. So let's start by having a look at where the transition metals are on our periodic table. So we've got our periodic table here, and the transition metals go between group 2 and group 3. So all of these within the central block are the transition metals. So let's take a closer look at them. Now we've got our top row here, the top period, which is period 3, and we go all the way from scandium through to zinc. But we normally focus mainly on these top two rows. We've got some common ones that you've probably heard of: iron, copper, zinc. We've also got silver, gold, platinum as well. Now, one of the good things about transition metals is that they're normally very colourful. So when they're in compounds, we've got copper here, which makes a nice blue compound. So you might know copper sulfate, which is blue. You've got iron, which can be two different colours. It can be grey-y green colour, or it can be orangey brown, and that's where we see our rust. But one of my favourites is chromium, that can be orange, or it can be a green colour. Now, the other thing that we've seen with the transition metals is we've seen them used for catalysts. So we've seen, when we did the Haber process, we looked at how iron is used, and then how nickel is used for the production of margarine. Thermal decomposition of transition metal carbonates is really quite useful. It's if we take the words thermal decomposition, thermal means heat, and decomposition means to break down. And when we actually get into class, we'll actually have a go at doing this reaction. Now, if we take this first one, we've got copper carbonate here, which is a lovely greeny colour. Now, when you heat this, the copper carbonate will decompose to make this copper oxide colour here. Now, with the decomposition of any carbonate, we're going to get carbon dioxide being present. So what will happen is the carbon dioxide gas will go through this tube and into the second boiling tube that's got lime water in it. Now, one of the safety things we need to be aware of is when we stop heating, we need to remove the lime water before we stop heating, because the lime water could suck back up to here, and where this is nice and cold relative to this is nice and warm, and the hot and cold mixture could cause the glass to crack. So let's have a look at what the actual reaction involves then. So if we start, we had copper carbonate, so we've got copper carbonate, and that thermally decomposes to make two things. The first one is copper oxide, and the second one is carbon dioxide. Okay, so let's have a look at the symbols for this then. With the copper carbonate, we've got Cu, CO3, and the copper oxide is CuO, and then carbon dioxide is CO2. So you can see that we've got one copper, one carbon, 3 oxygens, 1, 2, 3 oxygens. Now, what I'd like you to have a go at is the equations for iron carbonate, manganese carbonate and zinc carbonate, all undergoing thermal decomposition. So see if we can get those into our notes. Now, transition metal ions are quite unique. The metal ions that we have in the transition metals, some of them can actually be more than one ion. So for example, iron can be iron 2 or iron 3, which means that they either lose 2 electrons or they lose 3 electrons. Now, when you react transition metal ion with sodium hydroxide, we get a precipitation made. Now, precipitation means that we get a solid forming. So the precipitation is a solid that forms out of a solution. So it kind of drops out like rain. And we can see that if we took copper and we made copper hydroxide here, we would get a blue precipitate. For iron 2, we would get a grey-green precipitate for iron 2 hydroxide, and then for iron 3, we'd get an orangey-brown colour. Now, the orangey-brown would be similar to rust, and we can see our equations here for those ionic equations. The properties of transition metals are different from the other metals that we've seen. So we've looked at the alkali metals, which are very soft and not very dense in comparison to these metals. Now, all metals are able to conduct electricity, and we can see here copper has got the highest electrical conductivity, and we saw why that is when we looked at the metallic bonding earlier on. In comparison with the alkali metals, they're also very dense. You can see here that the numbers are very high for that density, and we can also see the relative hardness is also fairly high. Now, we know that copper is a good electrical conductor because we use that for electrical wiring. It's also good for saucepans as well, as it will conduct heat in a similar way. In terms of iron is used to make steel, which can be made into cars and girders, and again that's due to this relative hardness that makes it very strong. Now, in the exam you may need to be able to translate some of this data and interpret what it means. Okay, so we've looked at some of the properties already of the transition metals. Now, one of the other things is it is lustrous, which means it's very shiny. So things like gold, silver, platinum are very often used in jewellery. They're very hard, and that's due to their high density. They also have very high tensile strength. Which makes them good for bearing loads. They also have high melting and boiling points as well, definitely compared to the alkali metals that were quite low. Okay, well, I hope you've enjoyed this video on transition metals, where we have looked at what the transition metals are and how they can be used. We've looked at some reactions of the transition metals, such as the thermal decomposition of transition metal carbonates. We have also looked at the colours of the ions of the copper 2, iron 2, iron 3, and we've also looked at some of the properties of the transition metals. Anyway, I hope you've enjoyed this, and I will see you next time. Bye.